part A, the agent has to choose an effort level for task 1 and another effort level for task 2. And he wants to do so by maximizing his utility, which is equal to the wage he receives for working minus the cost that working has for him. We know that the wage is equal to a fee that the agent has to pay the principal for working, plus a percentage of y being equal to output of task 1 being equal to effort in task 1. So now that we know what wage is, we can substitute it in the utility function. And we get the following equation. As we want to know the optimal levels of E1 and E2, we now have to substitute the utility function with respect to E1 and with respect to E2. And we get the following results. If we solve for E1 and E2, we get that E1 is equal to beta plus E2 divided by 2, and E2 is equal to E1 divided by 2. So once we differentiate the agent's utility function with respect to E1 and respect to E2, we get two equations with two unknowns, the two unknowns being E1 and E2. And if we solve for both of them, we get that the optimal effort level for the agent for task 1 is 4/3 beta, while the optimal effort level for the agent for task 2 is 2/3 beta. So now that we know the optimal E1 and E2 for the agent, the principal has to get a beta that maximizes not only his utility but total utility, because we have the alpha in the weight. So we add the agent's utility because these two are total utility, but at the same time we have to add the agent's outside option because these two would be equal to 0. So principal's utility would still be equal to the principal's utility. If we substitute all the utility functions there, we get the following equation. The wages cancel each other because they're just a transfer of wealth, and what we really care about is about maximizing total surplus. We know that output in task 1 is equal to effort in task 1, and that output in task 2 is equal to effort in task 2. And as we got those two values in part A, we can substitute them in this equation. If we solve for this, we get that the principal's utility is equal to 2 beta minus 6 divided by 9 times beta squared. And as what we want to do is maximize the beta, we have to differentiate the principal's utility function with respect to beta. And we get 2 minus 12 divided by 9 times beta equal to 0. So the optimal beta would be 3 divided by 2.